This is water. This is water. Whoops, this is water. But why does it look and behave so differently? We're going to find out together as we explore the different states of matter. Everything is made of matter. Things like this. Matter makes up all the stuff in the universe. Anything that takes up space and has mass is matter.
All matter is made of atoms, which are in turn made of protons, neutrons, and electrons. Atoms hang out together to form molecules, which are the building blocks for all types of matter. Both atoms and molecules are held together by a form of potential energy called chemical energy.
Matter exists in different states. Today, we are going to investigate the three most common states: solid state, liquid state, and gaseous or gas state. In a solid, particles are packed tightly together, so they don't move much. The forces between particles are so strong that the particles cannot move freely, but can only vibrate. Because of this, particles in a solid have very low kinetic energy. Kinetic energy is the energy that an object has because of its motion.
Solids have a definite shape, as well as definite volume and mass, and don't conform to the shape of a container that they're placed inside. Conform just means to change in order to fit. Solids are true to themselves. They don't change for anyone, unless they get really uncomfortable under pressure or things begin to heat up. Solids also have high density, which means that their particles are packed tightly together. Solids can only change their shape by an outside force, like this.
In a liquid, the particles are more loosely packed than in a solid and are able to flow around each other, giving the liquid an indefinite shape. Therefore, the liquid will conform to the shape of its container. There. So cats must be liquid.
If I fits, I sits.
In a gas, the particles have tons of space between them and high kinetic energy. Like we'll see with this smoke machine, a gas has no definite shape or volume. If uncontrolled, the particles of a gas will spread out indefinitely, like this. If confined, the gas will expand to fill its container. Let's observe this with some smoke-filled bubbles. The smoke is a gas we can see, and the bubbles are a flexible liquid. As they stretch around the gas, they trap it. The bubble becomes a container for the gas. When they pop, the gas is released and dissipates. Understanding that because gas is matter, it must have weight in mass is a hard concept to understand unless you can see it. So I have a really simple way for us to observe this in action. This is a balance I have created with paper bags on both ends. Right now, both of these bags are filled with the same mixture of gases, the same gas that I'm breathing in right now. But let's change that. Now that we're goggled up, we're going to combine two very common substances, baking soda and vinegar. This chemical reaction creates carbon dioxide gas that we will pour into this bag. Do you see it going down just a little bit? As the carbon dioxide gas sinks into the bag, it's heavier than the mixture of gases on the other end.
If you're still here, liking this video, hit that subscribe button so you never miss an episode.
You may have heard of or even observed oobleck firsthand. It's a non-Newtonian fluid, a term for fluids that change viscosity or how easily they flow under stress. When you allow oobleck to flow through your fingers, it acts like a liquid. But if you apply rapid force, it solidifies and can even tear. Adding or removing energy from matter causes a physical change as matter moves from one state to another. For example, removing energy from liquid water causes it to become ice a solid, and adding thermal energy or heat to liquid water causes it to become a vapor or a gas. This energy either strengthens or weakens the force holding the molecules together, or the kinetic energy the particles have. We can observe this happening with these glow sticks. I have these 3 glow sticks that are all the same color and temperature. I've already cracked them open and started the chemical reaction. That's what makes them glow. If you want to learn the science behind this reaction, you can check out this video. You might be able to see already that there are different temperatures in each one of these glass containers. In this one, we have cold water with ice. This is room temperature, and this is hot water. Let's see how the glow sticks change behavior when we place them in each container. We're going to wait for 5 minutes and see what changes. You can't see the differences too well because of all of these lights, so let's take care of that. You can see a difference, especially here between the hot water and the cold water. Why do you think this happened? First, let's get these lights back on. Much better. Chemical reactions happen slower at lower temperatures and faster at higher temperatures because the molecules are moving faster at higher temperatures and slower at lower temperatures. The more heat energy, the more movement or kinetic energy that the molecules have. When heat is applied to a solid, its particles begin to vibrate faster and its particles begin to move farther apart. When the substance reaches a certain combination of temperature and pressure, its melting point, the solid will begin to melt and turn into a liquid. When heat is removed, the opposite happens. The particles slow down and move closer together. If enough heat is removed, the substance begins to freeze. When a solid is converted directly into a gas without going through a liquid phase, the process is known as sublimation. A few volatile substances will undergo sublimation at room temperature and pressure, such as frozen carbon dioxide or dry ice. The dry ice is a solid, but you can see that gas coming off of it and crawling over the surface of the desk. Vaporization is the changing of a liquid to a gas and can occur through either evaporation or boiling, like we're attempting to do right here. Because the particles in a liquid are in constant motion, they frequently bump into each other, and each collision causes energy to be transferred. Once enough energy is transferred to particles here near the surface, they may be knocked completely away as free gas particles, as you can see right here.
Condensation occurs when gas loses energy and the particles come together to form a liquid. For example, water vapor condenses into liquid water on the outside of your glass on a warm day. The warm water vapor bumps into the side of the cold glass and forms these little drops of water.
Matter is changing state all around you. See how many examples you can find today. And if you want to learn more science, you can check out this video next. Too intense. The oobleck is too intense.